move on. Let me now move on to something many of you might be waiting for, or maybe not. In Calc 1, I have lots of people who wanted to use L'Hopital's rule, and I had to always say that you're not allowed to use L'Hopital's rule. I hated to say that, but now you can use it. I wish we could finish L'Hopital's rule in Calc 1, but we usually don't. So in Calc 2 we do that. This is in the Calc 2 syllabus. This is from section 6.8. If you want to read the book, read section 6.8. Why didn't I do it before? Why am I doing it after chapter 10? Because we are going to need L'Hopital's rule in chapter 11, which will be the next chapter we do in this course. And I thought we should do it right before I start chapter 11. So there you have it, okay? So L'Hopital's rule. What is this all about? Many of you already know what this is. Okay, L'Hopital's rule. First of all, I'm going to state what the L'Hopital's rule is. I am assuming that A and B and C are three real numbers. A is less than C and C is less than B. And on the real number line, I gave you a picture of the interval from A to B, and C is in between. C is in between. Okay. My first assumption before I state the first assumption of L'Hopital's rule is you have two functions f of x and g of x, and we are assuming the derivative of f and the derivative of g is defined for any x between a and b except possibly at c. Okay? The derivative of f and the derivative of g is defined, right? Derivative of f and the derivative of g, both of them are defined at any x between a and b except at c, except possibly at c. Okay? The second assumption of L'Hopital's rule is the derivative of g is non-zero at any x between a and b except possibly at c. The derivative of g is non-zero at every x between a and b except possibly at c. Those are two assumptions there. Now, I can tell you what L'Hopital's rule says. We are looking at the limit of f of x over g of x as x goes to c. We are looking at the limit of f of x divided by g of x as x goes to c. If the limit form of this limit is an indeterminate form, right? If this limit has the indeterminate form 0 over 0 or infinity over infinity, what does that mean? When I say that this limit has indeterminate form 0 over 0, what do I mean? I mean that the numerator has limit 0 and the denominator has limit 0 separately. Right? So separately, the numerator has limit 0 and the denominator has limit 0. That's what I mean when I say that this limit has indeterminate form 0 over 0. Or when I say that this limit has indeterminate form infinity over infinity, what I mean is that the numerator has limit infinity, the denominator has limit infinity separately. Now, looking at those limit forms, you don't know what the limit of the ratio is. Just because the numerator goes to 0, the denominator goes to 0, doesn't mean that the limit is known. Limit of the ratio is known. The limit of the ratio could be anything, depending on what the problem is. Same thing for infinity over infinity. If the limit form is infinity over infinity, it doesn't tell me what the limit is. Sometimes I see students saying the numerator has limit infinity, the denominator has limit infinity, therefore it's 1. Okay? Totally bogus when you say infinity over infinity is 1. Why? And remember, infinity is not a number. You cannot cancel out infinity, right? Infinity over infinity simply says the numerator is becoming big, the denominator is becoming big as well, right? Doesn't tell you what the limit of the ratio should be. Why? Because the numerator might be becoming large very fast, much faster than the denominator, or maybe the denominator is becoming big much faster than the numerator, right? So depending on how they are becoming large will affect the limit of the ratio. Am I making sense? And you'll see lots of examples where you have infinity over infinity, but the limit is sometimes 1, sometimes 2, sometimes infinity, sometimes 0. Is that making sense? So, what is the conclusion of the L'Hopital's rule? If I am looking at the limit of f of x over g of x as x goes to c, if the limit has indeterminate form, 0 over 0 or infinity over infinity, then we can say that the limit as x goes to c of f of x over g of x is the same as the limit as x goes to c of f prime of x over g prime of x, provided the limit on the right-hand side is defined. Provided the limit on the right-hand side is a number or is infinity or negative infinity. Am I making sense? Provided that the limit on the right-hand side is known. Okay. Am I making sense? Well, one thing I want to say here. Notice that what is done by the L'Hopital's rule. It's basically saying the limit of f over g, right, is the same as the limit of the ratio of the rates of the two functions, right? So f prime and g prime, they have the rates of f and g, right? And a few seconds ago I said the rates at which the two functions go to infinity or 0 matters when you look at the limit of the ratio. Is that making sense? Let me give you a sort of a little bit of intuition here. Compare x divided by, or let's say 2x divided by x with x squared divided by x and x over x squared. And let's say you're looking at the limit as x goes to infinity. What is the limit form in the first case? In each case, what's the limit form? Infinity over infinity. Here it is infinity over infinity, infinity over infinity, right? In all three cases, the limit form is infinity over infinity, right? What are the limits though? What's the limit in the first case? Well, the first function that I have, the first ratio, 2x over x, is just a bad way of writing 2, right? So the limit is 2. What's the second function, second ratio? The second ratio is just a bad way of writing x, right? So what's the limit? Infinity. What's the limit in the third case? 0. Am I making sense? So I have the same indeterminate form, infinity over infinity, but depending on how these functions are, if you look at the third case, right, the denominator is going to infinity faster than the numerator, so that's why you're getting 0. In the middle case, the numerator is going to infinity faster than the denominator, you're getting infinity, the limit. And in the first case, the numerator is going to infinity faster than the denominator. However, the rate the rate of one of them is 2. The rate at which the numerator is increasing is 2. The rate at which the denominator is increasing is 1. So that's why you're getting 2. Am I making sense? So it does make sense that the limit of the ratio of f and g is related to the limit of the ratio of their rates. Okay? Alright, so let's, one more remark here. Even though I stated the L'Hopital's rule in terms of a two-sided limit, right? Limit as x goes to c. However, I could also look at the limit as x goes to c from the right, from the left. C could be infinity or negative infinity. Is everybody clear? L'Hopital's rule applies even if I have one-sided limits, or I'm looking at the limit as x goes to infinity or x goes to negative infinity. Yeah?
If c is going to infinity, wouldn't that be outside of the range from a to b?
Oh, in that case, my assumptions that I stated here will have to be changed. So instead of when I look at, say, x goes to infinity, then what I'm going to say is that look at an interval like this, some point to infinity, okay, some point to infinity, and I have to change my interval from a to b by something like that when I look at the limit as x goes to infinity. Am I making sense? I just didn't want to write down all that for every single type of limits. Okay. The main thing that the main assumption of the rule is that the limit forms the limit form is either 0 over 0 or infinity over infinity. Okay. Is that okay? So I was dodging that, but you're right that if I look at as x goes to infinity, then this interval would have to be changed to something like right open interval. Okay. Okay, so let's look at some examples then. Look at the limit. Never ever apply. What is that?
What was the remark?
Oh, the remark was I can use the L'Hopital's rule not only for the limit as x goes to c, but also for limit as x goes to c from the right or left, or also I can look at the L'Hopital's rule as the limit as x goes to infinity or negative infinity. So you can apply L'Hopital's rule for any type of limits as long as the limit has indeterminate form 0 over 0 or infinity over infinity. All right. What is the limit form in this example? Never ever apply L'Hopital's rule without checking the limit form. What is the limit form? What is the limit form here? As x goes to 1, ln of 1 is what? 0. What is the limit of x minus 1? 0. Can I apply L'Hopital's rule then? I can apply L'Hopital's rule. And L'Hopital's rule says I get the limit as x goes to 1. What is the derivative of ln of x? 1 over x. What's the derivative of x minus 1? 1. So what do I get? If I do some algebra, I get 1 over x. And what's that limit? 1 over 1. And I am done, right? So the limit as x goes to 1 of ln of x over x minus 1 is 1. Right? Very convenient to have the L'Hopital's rule. Is everybody okay? Any questions on that? Let's look at the second example. What's the limit form now? Now x goes to infinity. What's the limit of ln of x as x goes to infinity? What's the limit of ln of x as x goes to infinity? Infinity. What's the limit of x minus 1 as x goes to infinity? Infinity over infinity. Is it valid then to apply L'Hopital's rule? So I could say this is what? The limit as x goes to infinity. What's the derivative of ln of x? 1 over x. Again, I get 1. I guess we have done this. So this is limit as x goes to infinity of 1 over x. And what is the limit of 1 over x as x goes to infinity? Okay, let me say it this way. What is the limit form at this point? The limit form is 1 over infinity, right? Is 1 over infinity indeterminate? No, it is determinate, and the limit is 0, right? If the denominator goes to infinity, the numerator is going to a fixed number, the ratio will go to 0. Okay, so I get 0 there. Any questions on that? Let's look at the next example. What's the limit as x goes to 0 from the right? X over sine of root x. What's the limit form? As x goes to 0, the numerator will be 0. As x goes to 0, the denominator goes to what? Sine 0, right? What is sine 0? 0. So I do get 0 over 0, so I can apply L'Hopital's rule, and this would be the limit as x goes to 0 from the right. Take the derivative of x is 1. What's the derivative of sine of root x? Okay, first of all, the derivative of sine of root x, if you apply the chain rule, you get cosine of root x, and then you have to multiply by the derivative of root x, which is what? 1 over 2 root x. So 1 over 2 root x, that's the derivative of root x. Now you have to do some algebra here. So what can I do here? I can say that this is the limit as x goes to 0 from the right of what? Can I put 2 root x in the numerator? And I can write this. Is that okay? You guys agree with that? Is everybody okay? Algebra? Okay, now, what's the limit form now? What's the limit form now? Yeah, you get 0 in the numerator, and in the denominator you get cosine 0, but cosine 0 is 1, which is 0 over 1. Is that indeterminate? No, it is not indeterminate, it is 0, right? So the limit would be 0. Everybody's okay? How many of you have seen L'Hopital's rule before? 1, 2, 3, 4. Okay. Alright, so let's move on to the next. Here, what's the limit form? E to the x minus 1 over x squared. Yeah, when you plug in 0 for x in the numerator, you're getting what? E to the 0 minus 1, and then here you're getting 0 for sure, but e to the 0 is 1, right? So you get 1 minus 1, and basically then you get 0 over 0. So I am getting the limit form 0 over 0, so then I am allowed to apply the L'Hopital's rule. And if I apply the L'Hopital's rule, I get limit x going to 0. E to the x is the derivative minus 1, right? What's the derivative of x squared? 2x. Okay. So that's where I am now. And what's the limit form now? Yeah, it's still 0 over 0, so I can apply L'Hopital's rule one more time. The limit as x goes to 0, and now what's the derivative? E to the x divided by 2. If I take the derivatives, and then what's the limit form now? E to the 0 over 2, which means I get half. Is everybody okay? Now, can someone give me make up a problem where I have to apply L'Hopital's rule 3 times? What can I change in this problem so that I have to use L'Hopital's rule 3 times? X cubed. If I want to use it million times, x to the million. Right? Am I making sense? Well, if I put x to the million, would you really take the derivative a million times, or would you say, if you have e to the let's say at some point you're going to get e to the x divided by x to the power something, right? From that on, you can say that, if you just take the derivative n times, right? If you take the derivative n times, then where are you going to go? E to the x will remain the same, right? And then if you take the derivative n times, you get some constant right here, right? So that you know that the limit would be 1 over that constant, right? Am I making sense? What is that constant, by the way? Not n. If you look at x to the n, if you take the derivative the first time, you get n x to the n minus 1. If you take the derivative the second time, you get n minus 1 x to the n minus 2, right? So this is the second time. Third time, fourth time, nth time. What are you going to get at the nth time? Nth time would be what? N times n minus 1. Remember, the second time, what are you subtracting from n? The second time you're subtracting n minus from n, you're subtracting 1 less than so this is the first time, this is the second time, right? Dot dot dot. And nth time, what's going to happen? How far are you going to go? Up to n. The nth, in the second step, you're subtracting 1 from n, right? I mean, the last term in the product here, you're subtracting 1. The nth step, you're going to subtract 1 less than n, which would be n minus 1, right? What is that? That is 1, right? Okay, so that's nth step. You're getting this number here, c. C is that. C is that. What is n times n minus 1 up to 1? It is n factorial, right? That's called n factorial. What were you going to say? Okay, yeah, that's n factorial. In any case, I actually didn't intend to do that, but I got sidetracked. Okay, let's look at the second, this problem. In this problem, let's see, what's the form? 0 over 0, everybody agrees? 0 over 0, am I right? Do we get 0 over 0? Yeah. Okay. And this would be by L'Hopital's rule then, would be I can take the derivative, so 2x over e to the x. So just like the previous problem, I can take the L'Hopital's rule one more time. I get 2 over e to the x. And now what's the limit? 2 over e to the 0, which is 2. Right. Why did I say warning? Why did I write warning? Everything I did makes sense, right? Everything I did made sense? Yeah. Which one? Second step here. Okay. Yeah. So what did I do wrong? I didn't check the limit form before I applied L'Hopital's rule the second time, right? And at this moment, before I applied the L'Hopital's rule, I should have checked what's the limit form. The limit form here is what? 0 divided by e to the 0, which is 0 divided by 1. That's not indeterminate. So this limit should have been what? This limit should have been 0. And this is bogus here. Right? Is everybody okay? What's the point of this problem? Just to sort of my effort to make you remember that never apply L'Hopital's rule without checking the limit form. Okay? Alright. Next problem. What's the limit form here? E to the power 2x minus 1, right? As x goes to infinity, what is happening to 2 over x? So you're getting e to the 0 minus 1. And in the denominator, what is happening to 1 over x? 0. So you are getting 0 over 0, right? So the limit form is 0 over 0. I could apply L'Hopital's rule. And this is the limit as x goes to infinity. What's the derivative of e to the 2 over x? And what's the derivative of 1 over x? What's the derivative of e to the 2 over x? The derivative of e to the 2 over x is itself multiplied by what? Multiplied by the derivative of 2 over x, right? I usually use brackets, so let me use brackets. And in the denominator, I also have to take the derivative of 1 over x, right? Is everybody okay? Now, what's the derivative of 2 over x? Yeah?
How would you solve this one as algebraically? Take the 1 over x.
Well, it's going to become x times e to the 2 over x minus 1, and you're going to get into another limit form, which is indeterminate as well. You're basically going to get infinity times 0.
Okay.
Infinity times 0 is also indeterminate. I'm going to talk about that in a bit. Okay, so what is this? You see that I have the derivative of 2 over x, right? What is that? 2 over x, can I write it as 1 over x and then put the 2 outside? Now, you can write down the derivative of 1 over x if you want to. Let me do that, but you don't really have to. They cancel out, right? So I get 2 e to the 2 over x times derivative of 1 over x is negative 1 over x squared. Negative 1 over x squared for the derivative of 1 over x. They cancel out. I could have canceled them out right here. So then, what am I getting? I am getting the limit as x goes to infinity 2 times e to the 2 over x. What's that? What is that now? It'll be 2 times e to the 0, right? And which is 2. Is everybody okay? Any questions on this problem? Everybody's okay. All right. Other indeterminate forms, and I'm coming back to, yeah.
If you do take the derivative of 1 over x,
Yeah.
if you get, it's like 1 times 0 is 0. Once you take the limit of it, maybe.
Which one are you talking about?
If you take the,
If I take the derivative of 1 over x,
of the side on the right,
if I take the derivative of 1 over x, I get this, right?
yeah.
Minus 1 over x squared, right? Because 1 over x is what? 1 over x is actually negative 1. So if you take the derivative, you get negative, actually negative 2, which is negative 1 over x squared, right? So, and then I can cancel out the derivative. Is that what you said?
Yeah, I didn't take them out. No.
Oh, okay. Oh, okay. Yeah, you can cancel them out. And yeah. Okay, so there are other indeterminate forms. Okay, if you have, let's say you're looking at a limit like this, the limit of x going somewhere of f of x minus g of x, right? You're looking at a limit like that, and both of the summands are going to infinity. So you get the indeterminate form infinity minus infinity. Now, if you look at infinity minus infinity, should the limit be 0, right? The answer is no, not necessarily. For example, look at my first example here. What's the limit as x goes to 0 from the right of 1 over x minus 1 over x? What's the limit of 1 over x minus 1 over x as x goes to 0 from the right? Well, if you think about it, as x goes to 0 from the right, what's the limit of 1 over x? The limit of 1 over x as x goes to 0 from the right is infinity. The limit of 1 over x is infinity. So I get infinity minus infinity. What's the limit in this case? The limit is 0 because 1 over x minus 1 over x is 0. So this is 0. What is happening here? 2x goes to infinity. X goes to infinity. So the limit form is infinity minus infinity. However, what's the limit here? Yeah, not 1. This is x, right? 2x minus x is x. So the limit is what? Infinity. Next problem is infinity. 2 plus x goes to infinity as x goes to infinity. X goes to infinity as x goes to infinity. So I still have infinity minus infinity, but this time the limit is what? The limit is 2. My point is, knowing limit form infinity minus infinity doesn't tell you what the limit is. Same thing for 0 times infinity. So if you are looking at the limit of a form where you're taking the product of two functions, f and g. You're taking the product of two functions f and g like here. Then maybe the limit of one factor is 0, the limit of the other factor is infinity. Okay? Then that's an indeterminate form. It doesn't tell you what the limit is. The limit is not necessarily 0. Sometimes people see 0 times infinity and they say that the limit should be 0. No. The limit could be many things depending on the problem. For example, if I look at the limit as x goes to 0 from the right of x times 1 over x, what is that? Well, as x goes to 0 from the right, the first factor goes to infinity. The first factor goes to 0. Factor goes to 0. The second factor goes to infinity. In the second limit, the first factor goes to infinity. The second factor goes to 0. In the third limit, the first factor goes to infinity. The second factor goes to 0. What's the limit in the first limit? The first limit is 1, right? The second limit is a limit of 1 over x. And the limit of 1 over x is what? 0 as x goes to infinity. In the third case, you're taking the limit of x. Limit of x is what? Infinity. So sometimes it could be a finite number, it could be 0, it could be infinity, right? So both of these limit forms are indeterminate. And I'm going to do more examples on this tomorrow.
The dean or our instructor will send you an email.
Doesn't matter.
Okay.
I believe you.
Thanks.
Yep. You going to the seminar?
No, sadly, I'm leaving for Columbus here in like 15